PADS logic is a schematic entry or circuit design entry. We can opt to go into an existing design, but here we want to click on the new design. When you first start, you've got all this wasted space around here. If we click on these things, then these disappear. The navigation is done with the scroll wheel. I'm moving the scroll wheel up and down. If I use the shift key, then the scroll wheel moves it sideways, and if I use the control key, it zooms in and out. This screen is not the right size. You won't be able to print it, and the one important thing about it is being able to print. So when it first comes in, you need to be able to get rid of this title box, and the way you can do that is with right click, selecting anything, and then hitting the delete key, and it disappears. So now you've got a blank sheet of paper, but the sheet of paper is the wrong size, so we need to change it with tools, options, design, and we need to change it to A4. If we don't do that, you won't be able to print it, which is the important thing. But now we want to add parts, as they're called, which is the actual symbols which relate to things. So we need to know where to get the parts from. So files library is where we manage the libraries. Now the problem with the package is that it remembers the last user. Now the last user will have actually done something that you don't want it to do. So by doing manage library, you get this list. Now this list may have things on there that you don't own. So all you want is the basic C ones. So you have to remove any of the existing ones. If you don't remove them, then you just continually get error messages popping up. Right, okay, so that's your standard set of libraries. Now you will have to do that every time you want to use this package, because on every PC that's different. Okay, so when we want to add parts, then there's an icon called Add Part. When we click on that, we get this window. Here we can see that it's looking for all libraries. Now the way you select things is with this wildcard. So if we say something like RES star, meaning anything beginning with RES as a string, then what pops up is selections of resistors. So the wildcard for resistors is RES. Then we can add, and then we find that they're actually adding it onto the sheet, and then we can zoom in and actually see it there. We can add another one if we want to. If we want to change what we're adding, we go back to here, and if we want to put in cap for capacitor, then again we get selections of various capacitors. Let's add that one, add, and then we've got capacitors there. Okay, so that gives us the basic sort of set. If we want to do things like ICs and devices, we put in DIP, DIP, and what that produces is a set of different chips with different pin numbers. So there's a 10 pin, a 12 pin, a 14 pin. So you choose the device that you need. So then we can add, and then what we get is a part that looks like that. So when we close it, then we can add more if we want. So we talked about RES and CAP as wildcards. This list shows all the alternatives that can be found just by typing them in, all your normal components that you'll need during your design. Okay. We can move them, so we can place them around the design easily. Wiring things up, because they're disconnected at the moment. We go back to the menu, and this little menu here called Add Connection. There's a shortcut called F2, which is quite useful. So we add connection. If you notice the little cursor's changed to a cross with a V on it, that indicates that it's like a pen. And so we're drawing tracks. So when we click on them, we can actually then connect. Observe that the connections, if it goes to a component and there's a T-junction here, like a T, then it'll draw a dot. There's the dot. Okay, so we can wire these up in the same way like this sort of thing. So to be able to move things again, the important feature on pads is this right click. So I do right click mouse. These items are called parts. So if we select parts, we can select that, and look what happens. We haven't lost our circuit connection. These are still connected, and we can move the components around to give us our better layout sort of thing. This is an example that I created earlier. Again, it's in sections. So in other words, the circuit doesn't appear to be connected. There's a circuit here, a circuit there, but they are connected, and they're connected by these things called net names. Net names have to be identical names, but basically anything with the same name connects. So there's a GND there, that would connect with the GND here. And you can find where they were connected by doing right click, select nets, and then selecting it. And then all the white highlighted ones are all the connections with on the same net. Basically, they're all connected together. So we've got all the, and GND is a normal name for the common ground. So we can do that. We can say, where's the plus bat signal? And in fact, it just goes straight to a connector over here. So the simply most efficient way of drawing circuits is with net names. Keeping them isolated so that each section can be described with text, so it says exactly what they are on the tin, and how they're connected together. That's the important thing. And the way you do that is with if you've got a connection, you double click on the wire, and then you get this net properties come up. And then when you click on here, you can see all the existing ones that exist already, or you can actually create a new one. So if we wanted to create a new one from, say, this pin. If we want to add a connection, we go to Add Connection. Our cursor changes. We then go to the connection that we want to make. We click and double click, and then Escape. Escape will get rid of that entry mode. We then need to make sure that we're on Select Anything, because we're going to select that end. When we double click on it, we get a menu that comes up that shows the default net name. Well, we want to call it something sensible, so we're typing a REF, as it's called that on the chip. This option makes it visible. AREF. You have to do AREF after you've done the make visible. So when you apply it, it says, do you want to connect it? Yes, we do. So now we've made a connection to a ref. Now if we wanted to make a connection somewhere else, say down to here, then we do it again with the F2, say here, double click, escape, and then when we double click again, we can make it visible, but we can look down the existing list, and there's our one that we want to connect, the AREF. And we say OK. It says, do you want to connect it to the existing net, which we say yes, we do. So now what we've got a connection that's connected between this pin and that pin. OK, so now what we've got is a connection between this pin 1 and this pin 8. And again, escape and select nets. We can prove that it's there, because when we clicked on it, it actually says that it's highlighted. So that's a much better way of connecting devices together.